Guys, what we have here is a question which was asked in the 2015 June net exam. The question is that the Lagrangian of a particle is of a dynamical system is given by L is equal to half mx dot square plus mx dot y dot, and then its Hamiltonian is what we need to find out. This is extremely simple. We have already done several problems corresponding to such a situation where we are given a Lagrangian and we need to find out the Hamiltonian. Okay, so what we basically know is that Hamiltonian is sigma pi qi minus Lagrangian, where pi is the conjugate momentum and qi is the generalized coordinate. And for pi qi, because for all i's, because p could be different, there could be different coordinate systems such as that which we are given here, px and py. So we have to sum them all out. Okay, and then subtract it with the Lagrangian to get the Hamiltonian. Okay, that's effectively what we need to do. So first of all, our Lagrangian is in the form of x dot square and x dot y dot, which gives us the corresponding velocities in the x and y directions. Okay, so that you can understand easily. Now what we need to do is that we need to find out p. So first of all, pi, which is I is equal to 1, which is first px is equal to dou L by dou x dot. So that's px, that's Hamilton's equations, and py is equal to dou L by Jacobi Hamilton's equation y dot. And this we have already discussed this earlier in several problems and numerous amount of problems. So px will be time derivative of that would be mx dot plus my dot, and py would be just taking the derivative with y dot, you get mx dot. Okay, so that's it. That's px and py taking the derivatives. Now we can substitute them back into the equation, which is the first one, Hamiltonian, which is equal to sigma px, not sigma tx x dot plus py y dot, which corresponds to this, which all the sum of all conjugate momenta and their corresponding coordinates minus Lagrangian, which gives you px, which is mx dot plus my dot times x dot plus py, which is mx dot times y dot, minus Lagrangian, which is mx dot square by 2 plus mx dot y dot. So you can expand this and you get mx dot square plus mx dot y dot plus mx dot y dot minus mx dot square by 2 plus minus mx dot y dot, and this 2 will cancel and this one remains, and half mx dot square minus mx dot square by 2, which is 1 minus 1 by 2, which will you get 1 by 2, right? So you get 1 by 2. So it will be mx dot square by 2 minus or what, plus mx dot y dot, right? So it's 1 minus 1 by 2, which is 2 minus 1 by 2 is equal to 1. So that's the Hamiltonian in terms of x dot and y dot. Okay, but we need our Hamiltonian in terms of px and py, which is a Legendre transformation. So you can substitute the value from px equation. You can write down that from this equation you can write down that x dot is equal to py by m, right? So from this equation you can write down that x dot plus y dot is equal to px by m, right? You know that x dot is equal to py by m, so it's py by m plus y dot is equal to px by m, which means that py dot is equal to px y dot is equal to px minus py by m, right? Okay, now we got y dot, we got x dot. Now we can substitute them back into this equation. You get m into y dot is py by m, x dot is py by m into p square y by 2m square plus m into x dot is py by m, which gives you py by m times y dot is what? Y dot is px minus py by m, right? So that's it. So this will be m into m and m will cancel and you get py square by m 2m plus m and m will cancel and you get py px by m minus py square by m, right? Yes, py square by m. So py square minus py square m 2 by 2m minus py square by m is 1 by 2 minus 1, which is equal to 1 minus 2 by 1, which is equal to minus 1 by 2. Oh sorry, 2 minus 1 by 2, right? So it's minus 1 by 2. So you can write down that this is equal to what? This is equal to py square by 2m minus 2m plus py px by m. It's just manipulation. So this is the answer, which is the correct answer, which would be option C, right? So px py by m minus py square by 2m, px py by m minus py square by 2m. So that's the right answer. I hope you guys understood this question very well, because this was comparatively very easy. You don't have to do much, you just need to know what you need to know is the manipulation of this question based upon the fact that Hamiltonian is the Legendre transformation of the Lagrangian. Okay, so basically we have covered that. For more videos you will get to this link to .me CSI and physics. Okay.